I think what's interesting to me about this whole kind of experience and endeavor is that we had some assumptions about galaxies, about how they form stars, how many stars you would make out of how much material. And we used all of the data we had from nearby galaxies to inform us based on these understandings. And I think what we did is we projected those understandings of galaxies that exist in today's universe to galaxies that existed in the early universe. And I don't think that we accurately accounted for how different the universe was itself in the early times and how different these galaxies were. And we didn't have a way really to see them to begin with, so that we couldn't, kind of hone in on the right properties for our models. But I think what we did is we naively took our own universe view and applied it to galaxies that lived in a very different environment than the ones that we see today. And so we are learning how better to recalibrate our expectations and to account for the fact that galaxies early on didn't have enough generations of stars to explode into supernova and then fuse heavier elements. So they just didn't start with as much, dust that, we have in our galaxies today. We also see stars in the early universe that are larger, based on the fact that if you have this much light in a star that doesn't have heavier elements, it's just hydrogen and helium, and the lighter elements, then you have a larger star for the amount of light it emits. And so when we do a lot of conversions from this, how much light there is, to what that would equate to as mass, like how massive is this galaxy, those conversions were incorrect because they were calibrated to galaxies that had stars that were made up of different elements. And so I think that's the fun part about this, is that we needed to rethink how we were thinking about galaxies in the early universe and not apply our own biases to these galaxies that were fundamentally different. And the universe was much smaller.
So what does that mean? So that the formation of heavier elements took longer than people thought? Or, I don't know. What's the implications of this?
No, I don't think that there's any... honestly, personally, I don't think that there's any, fundamentally incorrect assumption we had about the universe. But I think the way that we typically measure physical properties from the light of galaxies, those equations that we use, we were not calibrating them properly. I don't think that we've found something incredibly surprising or breaking what we expected, other than, I don't think our expectations were correct. So I think what's interesting about JWST is before this telescope, before we had this data, there were maybe a handful, but less than 10 sources, galaxies that we knew about for sure that existed in this time. We couldn't really study them in a whole lot of detail. We just didn't have the technology. I mean, within the first few months, we're looking at hundreds of galaxies. And over the last year, we have more galaxies than I can even remember. I'm so used to just knowing what those 10 sources were, those 10 galaxies are. And now we've got so much data that we are putting into context. A lot of the sources we knew about are going to be the rarer ones, right? They were brighter. That's why we were able to see them before. But now we want to understand, like, are they normal? Is that common for galaxies in the early universe to have those particular properties, or are those galaxies, the rare, unique ones? I mean, we have a lot more data to do something statistically significant with, and we're still trying to, go through all of it. It's a lot of information and trying to put a lot of things into context while also being aware of our own biases in our understanding and interpretation, but also in the observations, right? The first year we pointed at all the stuff we knew about already. That was the most logical thing to do. But is there some bias in looking at the things that we saw before? Those were bright sources. So I think what we're going to see in the next year is a lot of data that is of galaxies we just had no idea existed before. We couldn't see them, and we'll be able to understand in a larger sense what the early universe was like, what those galaxies were like in general, and not in unique, rare cases.
What particular questions are you trying to ask or answer with your proposed, visualizations from James Webb and from existing ones that you're looking over?
Yeah, so I think what we really want to understand is how different were these sources? Did they form stars faster? Were they more efficient with their material and converting it into stars? How did the black holes, the supermassive black holes at the center of these galaxies, how did they grow? What did they form out of? How fast did they grow in a galaxy that's also growing? How often did galaxies merge? And what was the impact on those mergers in their growth? Right? Did they merge and then, kind of two and two add together, or did that disrupt the process and kind of break them apart? I think there's a lot of really interesting questions about how galaxies grew from very early and their black holes grew into the ones that we were able to observe in much more detail prior to JWST.